Good afternoon, friends. Welcome to the STP training webinar, Getting Started with Automation. Our speaker for the day is Curtis Stuehrenberg. I'm Smita Mishra, a professional tester myself, and I'm excited to host you all and Curtis on our STP trainings. Before we get started with Curtis, let me share some quick information with all those who have joined us. We have our conference Fall 2017 STP Con coming up in the Washington, D.C. area from September 25th through 29th this year. As you can see on the screen, we have various certification courses through these dates. There are workshops through September 26th and 27th, and conferences and sessions through September 28th and 29th. The conference topics this time include automation, agile, performance, DevOps, mobile, security, leadership, strategy, and so much more. And we typically have over 16 workshops and maybe more than 40 sessions spanning across various formats like case studies, hands-on exercises, and tool demos. The complete program is already published, and you can actually explore the same at stpcon.com. And if you register by 26th of August, you get to save up to $400 off your registration. So the date is 26th of August. As a tester myself, I have found conferring to be one of the best ways to learn and also to get to know reputed testers across the globe. I've got to build my network connections all through, mostly at conferences. So I hope you all also find it to be the same way. If you are on Twitter, please share the conference information and about this webinar with your followers, connections, friends, colleagues. We love the shout outs. And if you hear something you like during this webinar or otherwise about STP, please tweet about it and use @SoftwareTestPro for a retweet from us. Another quick piece of information that I have for you is that there is an upcoming webinar, Make Your Automation Behave, Extending Your Framework for BDD by Angie Jones on 28th of June. The link is up for you to review and register. Angie is a renowned speaker and has spoken at STP in past. She's getting hugely popular amongst various testing forums and is a hands-on practitioner on automation. So I really hope you go for it. All right. So let's get started with the webinar today. A very warm welcome, Curtis. We are very thrilled to have you with us today. And let me quickly introduce you for all of us here. Curtis is a specialist master with Deloitte Digital based out of their San Francisco office, where he focuses mostly on software testing and quality assurance, better practices, and on building out and managing a company-wide center of excellence. Before joining Deloitte, he spent nearly 2 decades pursuing the career and his craft with companies spanning multiple industries and sizes. Curtis is actively involved in the larger software testing and quality assurance professional community through his writing, speaking, mentoring, and organizing work. He's a co-founder of the Bay Area Software Tester Professional Organization. He's a published author of multiple print articles on software testing and is a contributing author to the book, How to Reduce the Cost of Software Testing by CRC Press. He's also a sought-after speaker and has presented talks and classes at such conferences as the ALM Forum, STPCon, CAST, Agile SF, and the Wearable Tech Conference, in addition to his commitment to smaller events around the San Francisco Bay Area. So there is so much more I could actually talk about his vast experience and involvement with the community, but I'll let him do the rest of the talking. And just before we start, a quick few housekeeping points for next 1 hour. All the attendees shall remain in listen-only mode, like you'll be muted through the webinar. You can type in your questions and share them with us through your question or chat box, whichever appears based on your version of GoToWebinar. And we shall take them up as and when Curtis will go through his presentation. The webinar is recorded and it will be posted on Software Test Pro site for the attendees to go through later. So do not worry about trying to find the slides or something. You can just focus on learning and asking questions. All right, Curtis, very warm welcome again, and the floor is all yours now.
Thank you, Smita. And also thank you for letting me talk, sort of brag about myself a little bit. Just to sort of give everybody a sense of where this talk comes from. as Ms. Smith has said, I am a specialist master with Deloitte Digital, which is a subdivision of Deloitte Tamahatsu, Deloitte Touche Tamahatsu, one of the largest consulting companies in the world. In that role, I get to meet a lot of different people in a lot of different industries, and it sort of challenged me to step outside of where I had been working before, which is deep within the sort of disruptive, innovative world of San Francisco startup technology. When I did that, and I began working with some of these people, one of the chief information officers at a company I was working with asked if I'd be willing to sort of step in and give a talk to other chief information officers about what automation was and how it could benefit them. This really struck me as an odd request because it seemed like everybody I had worked with before understood automation, understood what it was, understood how to do it, and it made me realize that that was a very myopic or a very small slice of people out there who are working with software and maybe looking at how we can do things like speed up our time to market, how we can release product with more comfort level of our risk exposure, and automation seems to be the way to do that. It also awoken me to the fact that there are some interesting ideas about automation and its role within software development. So I sort of created the, I guess, the first draft of this talk to talk to them, and every time I've given it, I've gotten a lot of feedback, and so it's grown. In fact, just recently I was having an interesting conversation on Twitter, which sparked a whole new section of this talk regarding like what is in fact automation, because even a basic question like that seemed like it was self-explanatory to me, but apparently it's not. So I thought I would give my ideas about what automation is at its heart. So that's where we're actually going to start. A couple of ground rules for this talk. It's going to be a very, very, very fast talk if we don't have some engagement. So again, all of my talks, all of my webinars are meant for you who are listening right now. So thank you for showing up, but please don't be a passive listener. If you have questions, please put them in the chat window, and I have got some time here where we have open areas for discussing what was just talked about before for a question and answer period. Please feel free to pick my brain or talk about something that you may not agree with or something you'd like to hear more about. So with that in mind, let's get started. So what we're going to be going over here is some basic questions about why do we automate anything? What are the basic concepts of test automation? What is the difference between automation and using tools? How does test, you can read all of this stuff yourself. But as you can see, what this talk is going to be about are the basics about strategy and theory around software testing. We're going to go into some of the tools and some of the extensions that are out there right now that are being used both at a subscription level as well as open source. What this talk is not going to be about is me sitting down and telling you this is how you should automate things, this is the tools you should use, this is the strategy you should approach. Even as a consultant, I found that the best thing to do for an automation suite or tactic is to tailor it to what your software and what your development process is. Probably the worst mistake I've ever seen is having people try to drive an artificial construct of an automation strategy because they read this is what you're supposed to do and then try to insert it into an existing and well-running software development lifecycle. So always, always, always tailor what your automation strategy is going to be around how you build software and do it successfully. Otherwise, you're going to be making both of these exercises much more difficult than they need to be. So again, if you're looking for something to me to say this is the best practice for how to do it, this is probably not going to be a webinar for you. So moving forward, what is automation? Automation is at its heart, it's a tool. Anything that we do, everything that computers touch on is a tool for us to do something as humans. So that tool, specifically in this case, is a computer. And the computer does repetitive tasks over and over again, rapidly and with consistency. So in other words, they were built to be able to make a bunch of random computations, or not random, a bunch of structured computations to say, start here, go to here. They will do that rapidly, they will do that the exact same way every time, and they will do it endlessly, as long as you let them. In fact, some of the early ideas about for loops and whatever were mistakes where they would just do it endlessly and then cause problems. So humans, on the other hand, are the tool users, and they are the ones that sort of come up with this idea about what should we be doing, what's strange, what's happening, is the need being met. We're answering the larger questions about sort of fit and feel and oddness. So this translates into automation in the way that an automation is looking at something and saying, this is an expected behavior, this expected behavior occurred, true or false, pass or fail. It thinks in a binary condition, pass, fail. Humans don't necessarily think in that way. We are problem solvers and explorers, and we think in a relational system way. So we create patterns within our head, and we use that to react with the rest of the world. So we're the ones who are looking at something going, that's weird. That's sort of not what I expected. Let's dig into that a little bit deeper. So where automation comes into this process between the human testing of the traditional functional manual testing versus the computerized testing of automation is that when things become binary, when you know what's going to happen and all you're doing is checking to see if it's going to happen, you turn that over to a computer because a computer is going to be much better at that. And that's kind of a controversial statement, it turns out, but what I mean by that is a human being is going to get bored. A human being is going to get tired. We don't do repetitive actions very well. This was the entire basis for scientific math management during the beginning of the industrial age, where they tried to turn people into cogs in a machine, and it wasn't very effective. So they came up with ways to control the human to make them more like a machine. What ends up happening is if you ask someone to do the exact same thing over and over and over again, is they stop paying attention. Their body turns into a muscle memory and they just begin running it. They don't watch what they're doing, or they start cutting corners, or they start getting creative despite your best efforts. They start saying in a test case pattern, if you have a test suite you need to run that's say 100 test cases, they will look at that suite, and if everything's been running the exact same way for a couple of weeks or even a month or two, they'll start looking at that test suite and saying, well, you know, I could run every single step, but I know it's going to kind of happen. So if I run step 1, 14, 35, and 20, and maybe 56, and then the last 10, I know I'm going to cover everything, so I'll just run those and then mark everything else pass. The trouble with that is they're making an assumption, and that's when things slip through. A computer, on the other hand, will never get bored. It will never stop doing that thing. It will do that thing the exact same way every time, as many times as you ask it to do it. So when you're looking at this thing saying, this is exactly what I want to know, true, false, did this happen true, did this happen false? Have the computer do it so they can walk through it and say, this is exactly what happened, I did it the exact same way every time, we know that this is what's going on, we're good, move on. The other issue that we're sort of looking into is where should you invest your money in automation? What should your automation suite look like now that we've established these are tools that are good at taking repetitive tasks off your plate? This is the sort of automation pyramid. The first instance I had of this was looking, I think it was Lisa Chrisman was talking about this. I've since modified it just a little bit to be more up to date with how software development is happening right now. As you can see, the broadest spectrum of where you should be looking at is unit tests. And when I say the phrase unit tests, I mean tests that are written by the development team to verify the smallest functional point of software that's possible. So that is not saying we are going to be testing the functionality to say this is what it looks like. That it can work that way, and you can expand it out to be that. When you start looking at things like test-driven development or even specification by example, you can start doing that sort of behavior. But this should be where most of your automation occurs. It is generally going to be below the user interface level. It is going to be deep in the code. It's going to be exercising things and verifying that nothing is broken on that. This is going to be the cheapest automation because it's written at the time that you're writing the code. It's going to be the fastest to operate because it's only operating a specific set of functions. And it's going to be the stuff that your developers are going to then use to say, if I make this change, should I break anything else? So this should also be run as many times as you possibly can. And then as we start moving up that pyramid, you should have less and less coverage as you move your way through, all the way up to acceptance tests or the end-to-end testing. That should be the least amount of time that you spend on things, because that is going to be the automation that's the most difficult to create, because generally you're going to have to be using some sort of third-party tool to do it, like say Selenium or UFT or something like that. It's going to be brittle, because if anything changes, that binary condition is going to break. And it's also going to be the slowest, because it has to navigate through a bunch of stuff to try to get to the point where the binary condition sits. So the trouble I've seen coming forward is that when people start talking about we need to have automation, generally the request that we get is that we start with the end-to-end automation. They come in ahead of time and say, we have 2,000 regression test cases, and we need to automate those because it's taking us too long to run regression. So the first question I generally ask is, okay, well, where are your unit tests? What are your integration tests or your system tests? You can flip these back and forth if you want to, within system integration. But where are your layers of tests that I can look at to see if we can start cutting some of these end-to-end integration tests? Generally, if there are any, it's sort of an unorganized affair that people are putting in and storing wherever they want to, and whether they're being run and recorded is no one's quite sure. So, but people know they need to have automation, so they want to start investing a ton of money in the most expensive testing, as well as the one that's going to be the most brittle and is going to cause the most issues. Also, stepping back a little bit, when I use the word brittle, what I mean is things that are going to fail for a reason other than what you were hoping it would fail for. So that can be anything from the functionality changed, which you can also argue might be a valid reason for a failure if the functionality change was not communicated to everybody in the team, but that's more of a process problem than it is a code problem. It can be that there was a timeout because it took too long to go from one page to the other, which could be a problem with performance, but it could also be a problem with the tool that you're using because it takes too long to scrape the page or something like that. Basically, brittle means it failed and we don't trust that it's a failure that we need to go into the code and try to fix. So that's going to take time for you to track down what the actual problem is, identify that problem, and then try to figure out if that's an issue you need to work through, either from a test standpoint or from a code standpoint or whatever it is. The ones that are the least brittle are going to be our unit tests because, again, they are just testing that one piece of code. So if it fails, you know something within that one piece of code is not behaving as expected, either because it was given a different input or because somebody changed something that they didn't realize they were changing on this piece of code. So again, this is the basic pyramid, and it's a great visual about what your strategy should look like when you come out of the exercise of either adopting or trying to pivot and make your automation suite a little bit better. So since we talked about regression testing, this is going to be, I'm using this quote here from Joe Harder's Going Through the Motions, published in 2009, sort of reiterating this idea that humans are not very good at repetitive work that doesn't require a lot of insight or thought. He was using this phrase to answer the eternal question about when should we stop testing. I'm using it to say when you should start writing things as a regression test cases. Now, this is going to go into my working definition of a regression test case. So a regression test case, for my definition, is a test that's looking to see if there was an unexpected behavior change in the product in an area you didn't expect. So you're looking for known unknowns. You know you changed something, but you're unsure what the full impact is going to be on that change. So regression test cases are like the last check you have before you sort of push something out to say, is this true? Is there are assumptions about how this piece of code we changed, how it's interconnected to everything, is that actually true? Or did we miss a connection somewhere? Or did we miss something we were not expecting to find? That is the role of regression test cases. That regression test cases should not be something you say, okay, well, we have to run these every single time because these are the test cases that we run. Because again, that's a bunch of wasted effort. You're going to end up with things that are duplicates of each other. You're going to end up with test cases that are retesting the same stuff over and over again for no reason. And you're going to end up with a lot of effort that is generating no real benefit. So when you start looking at that question and you start saying, this is where we know that that we made this change, did everything break? You can start looking at regression test cases from a sort of object-oriented standpoint. You can start looking at it and saying, okay, we know we changed this piece of code in the following functionality. Let's run all of the regression test cases for that functionality. Now let's start running the test cases for this functionality that feeds into it, and you can have a staged program, which is what you're looking at if you're looking at doing something like continuous integration. That's how you do a continuous integration with automation, is you start from the very small and expand your way out and look for failures before you start running everything end-to-end. If you start with end-to-end, you've lost that ability to sort of zero in rapidly to say what was the problem, because you have to start digging through all of the other stuff that's going on to say what's happening, and you generally have to finish everything to say what's the full scope of what's going on. So let me just advance a little bit. So again, this is a visual about what your regression strategy should look like. I'm using this thing because whenever we move into a new place, we end up painting. So there's multiple ways you can paint something. Generally, if you're painting a wall, you use a roller brush. Not because that gives you a better sort of paint feel. It's because it covers the most area in the least amount of time. So when you're looking at your regression test cases, as far as automation goes, don't look to automate every single test case you've ever written. Again, that's going to be wasted effort. You're going to end up duplicating a lot of stuff. Go back to that idea to say, what happened when we changed this thing? Is there a break? So all you're looking for is an indication there's a problem so you can dig into what the actual problem is. So take a look at your test cases to say, okay, we have 74 test cases that have sign-in in them. Do we need to run all 74 of these to test sign-in? No, probably not. So you can start ejecting test cases to say, well, if this test case fails at sign-in, we're going to know there's a problem with sign-in, so let's dig into that. If this test case fails, we're going to know there's an issue with account management. Let's dig into account management and start running some test cases for that at the integration and system level. What you're looking for is an indicator. In some talks I give, there's this idea of the spotted owl that I talk about for people in the United States, which is part of the Endangered Species Act. Now, the Endangered Species Act exists so that certain species can be notified and protected if they start to go extinct, or if their numbers start decreasing, or if something happens to them. Now, the reason we do this is not because the spotted owl is an incredibly specifically valuable animal. It's really not. It's beautiful to look at, but it's really not that valuable compared to other species. Why we protect it is because it is what we call an indicator species. If something starts happening to the spotted owl because of where it sits within that ecosystem, we can understand that there's going to be bigger problems elsewhere within the ecosystem. In the case of the spotted owl, it's because it eats all of the different small rodents that exist within the under canopy of the forest. So we know if the spotted owl starts to go away, that something's happened to either its home, which are the trees, or its food source, which are the small rodents. So we can know to look into these areas to say what is happening in these other areas that's causing the spotted owl to go, just numbers to dwindle. And we can look at what the impact of the whole ecosystem is going to have on that. This is the same thing you're doing with the regression strategy. You're looking at spotted owls. You're saying, if this test case fails, we don't necessarily, it may not necessarily be that the spotted owl itself is just dying out or this regression test case is failing, but it should be an indicator to say what is happening with this entire system that's causing this test case to fail. Let's dig deeper and understand what the problem is. You do this so that, again, because the other problem I run into is even with automation, when we go in to talk to customers, sometimes even if they have an automation suite, people don't run it that often because it can take hours to run, or overnight, or even days or weeks to run their full automation suite, just because the test cases are slow, because there's so many of them. I mean, this generally happens with manual testing, but I've seen automation test suites take a couple of days to run as well. So again, the point of this is to get feedback quickly and to have it happen so that you can react to it. Anytime you're doing software testing, automation is no different. So I'm going to open this up for questions because I know I probably just like threw a bunch of stuff at you guys.
Okay, so I'll just read out. We do have a question from Paul Merrill and another one.
Of course we do.
Yeah, so he's saying, you mentioned the term stage program. Can you define that?
Oh, what was the term? I'm sorry.
Stage program. And he says, great job, by the way.
Stage program?
Stage program, yeah. S-T-A-G-E, stage program.
I have no idea. I didn't even know I said that phrase. I apologize.
In fact, yeah, I didn't hear that either. So, Paul, maybe we'll. Okay, so maybe I misunderstood something specific, but we'll come back to that. There's another question that says, can we also do automation for sanity test cases?
Oh, yes. Yes, you can. It depends on what you're trying to do with the sanity test, though. So you can run automation, but remember, the automation is just going to tell you, you know, binaries, pass, fail. So if you're looking at sanity testing for release, like we're going to be releasing this into staging, the point of a sanity check is to have something run within a couple of minutes, like say 5 or 10 minutes, to say, you know, did anything really, really bad blow up? My experience with this has been that humans are a little bit better at running these sanity checks because it should only, again, it should only take about 10 minutes to run them. I think 30 is the maximum I would suggest running these on, because then you're running into fatigue and you're running into coordination issues, because generally on a release you've got like 8 people on the phone and 3 of them are generally going to be very highly paid people and everyone's going to be nervous. So having a human run through like just a high-level scenario to say, let's try this, let's try that, oh, that looked weird. Again, that's a human response to say, that looks weird. So on the other hand, if you're talking about a sanity test, as in somebody runs like a very small suite to say, as they're writing code, or before they do a check-in or a pull request, yeah, totally, automate that.
So,
you know, keep it focused into the specific area that you're writing the code for. So you can have things like tagging, and we'll get into some of the test extensions that allow you to do things like, say, tagging or grouping of test cases with some sort of labeling program that allow you to do that. So you can say, I'm checking in a code to this following library, run the sanity check for this library. And that should take like 5-10 minutes, and you're taking a cup of coffee, come back, and your test cases are either passing or failing, and you're good. So I interrupted you, Smita. Go ahead.
Actually, Iram asked this, and there's a follow-up question from Iram again on top of the same question, that is it mandatory that our product is stable before automation?
I would say yes, because it goes back to when you're being bored. We go back to that. Let me go back to this slide here real quick. How do I do that here? So again, so if we accept this sort of definition as when testing is stopped, and by testing I mean that, you know, human interaction either through manual manipulation or through tools, or through manual manipulation using tools, or through, you know, writing tools that then give you feedback you can react to. I'm not sure how you could get to the state where you stopped being surprised or learning things if the code is not stable. Usually there's a point of stability where you sort of reach, but I'm going to qualify this by saying that you don't have to have the entire solution stable before you write automation. And you can start writing automation based upon your expectations of what that should look like. That's the whole purpose of specification by example in test-driven development. Test-driven development is, and specification by example is, you write a test case and then code to the test case. So under those conditions, you would always be writing automation before the code was stable, because the code doesn't even exist yet. And in the case, so also you can be writing automation for so let's also look at say a Scrum development pattern. So you could be writing automation for the user story that you're releasing. And the user story could be, ready to go. You demo it. It's out the door. There's automation for it. But there might be a larger epic or a larger sort of value proposition that you're coding, that you're building toward, that you haven't reached yet. That may not be stable. So does that sort of answer the question?
I would think so, yes. So there's another question from Satinder. Yeah, there's another question from Satinder. He says, we used to put a lot of effort on Selenium GUI testing and in maintenance of same. Do we need to focus more on the other area present at the bottom, like the pyramid that you showed? So should we focus more on that?
Yes. That was an easy one. Yes, you should. Just one second. Yes, you should. Selenium is a very, very good tool, and it is a great way to get started with automation, and it's a great way to do the sort of the second to top layer as well as the top layer for automation. You can automate end-to-end scenarios using Selenium on a web browser. You can even use the Selenium engine to automate mobile devices now using Appium. I'm skipping ahead to some of the tools we'll be going over. But again, that's going to be a little bit brittle because you're then going to have to do things like, say, scrape the DOM or use XPath to find the objects you're looking for, which take time. Most websites these days do not have a huge amount of code on the front end, on the GUI. Most of their code is going to be sitting in the back end at either the web service layer or even at the data integration layer. So spending more time coding that, writing test cases in, like, say, SoapUI, or even writing your own web request and response engines to be able to deal with these things going back and forth, is going to be more beneficial for you because it's going to be faster, and it's going to then isolate where the problem is. If a problem happens in Selenium and you don't have things happening at the web request layer, you're not going to know if it's a problem with the front-end code, maybe some JavaScript, maybe some AJAX controller or whatever it is that's going on, or if it's a problem with the web request, or even if it's a problem with the data transfer layer. So again, the issue here is not that, we get the most coverage. The issue is to be able to look at that automation and confidently respond rapidly to what's going on. So I would also argue that if you were running these sort of web request and response layers, we'll just say web request tests, you could run those ahead of the GUI thing to say, okay, we ran into a bunch of errors doing the web request for this area. Let's not even bother doing the Selenium test for this GUI because it's going to fail. So, oh, I just had. So, I mean, hopefully that answers the question. But again, this goes back to, we shouldn't stop doing it, but we shouldn't put all of our effort at that GUI layer or at the acceptance test layer. All right.
Okay. So
we're gonna
do we have time for more?
Let's keep going because we have a couple more things to talk about, and we're already at the half-hour point. So let's just keep going. Okay, DevOps. This is something else that came up. Generally, and I bring this up because just based upon experience, whenever we've been talking to people about trying to do an automation strategy, there's a fair to likely case it's because people want to start doing some sort of DevOps or continuous deployment strategy. So I added this. This was the initial request from the people who are the chief information officers. So I just said, so this is where this whole thing started, and this is where we started talking about what is going on, because it seems even talking amongst 5 or 6 people, we would sort of get 5 to maybe 7 to 8 definitions of what DevOps and continuous integration was. So we're going to start here with some basics about what that means and what that looks like, and then where it's probably going to be good to do it and where it might not be. So, this is the required terminology when you're walking into it. What are we talking about right now? Because CI, continuous delivery, and continuous deployment are actually 3 different things. You may hear them used interchangeably, but you shouldn't, because they're not the same thing at all. Continuous integration is something that I personally was doing as far back as 2000, and that's basically just sort of merging things into a common branch and then testing off of that. So what you end up doing is you have some testing that happens on the different branches, and then you merge them together, and that becomes the master branch. That is all continuous integration is. So because before, when we were running sort of the phase-gated approach where we had entrance and exit criteria, that integration wasn't happening until we met the exit criteria to go into the testing phase. CI moved that into a continuous process into the development layer. So now people weren't just coding in a silo for their own development thing, they were actually merging things together to see how they reacted before it got into the testing phase. So that's where that started. Continuous delivery means that we are not just merging things together, we are creating them into a package that is then deployed or delivered to a testing environment. So this could be anything from the dev environment that you're building it into, or the QA or staging, or even production. I was working with a couple of smaller scale customers that their testing was actually being deployed to a production environment because that was what they could afford, but they were covering everything up with feature flags and the like so that they could test within that environment but not impact the actual users they had. This was a good strategy for them because they didn't have a huge amount of users that were active. They had enough that they could attract investors, and they could attract attention from the press, which is what their main goal was. So keeping their existing customers happy was a good goal, but their ultimate goal was to have an environment where they could demonstrate what they were doing on the fly and not have to spend like double to 3 times the amount of money maintaining 3 different environments. So, and then we have continuous deployment, which is the one that everybody refers to when they talk about like what Facebook does and things like that. That is the mothership of what we're talking about here. That is, things are built, they are tested, and they are deployed right to production as fast as you can. And it's a continual process. It happens as soon as something is approved. So you don't have a big release, you have a bunch of micro releases that are going on. So what that looks like in the real world for people who are successfully doing this is this. Facebook typically rolls out a minor update every business day. Every single day there's a minor update that they roll out. Major updates are about once a week. This was back in 2012 that they were talking about this. My understanding is that they might have actually sped this up, but this is what I'm going to quote because it's what I could find. And this is across their entire product stack. So they're constantly rolling things out. Etsy, on the other hand, does 50 production releases to production in a single day, and that's on average. So they're doing 50 micro releases to their product live every single day. Amazon does a new release to production every 11.6 seconds. That is what continuous deployment looks like. That is the speed at which they operate. They can do this because they're doing what's called micro releases or sort of minor releases or things like that, but they're also doing major releases as part of that as well. It all gets put into the same queue and it all rolls out. The other reason they can do this is because Facebook, Etsy, Amazon, Google, all of the things you can name that are doing this sort of release have spent years and millions of dollars building out a system that allows them to do this with confidence. You hear the phrase that people need to be allowed to fail. Well, that's one side of the coin. And the other side of the coin is that they need to have confidence that if they fail, that it's not going to hurt anybody. Because the type of employees that you want are not just going to be the ones who like to make mistakes. They're going to be the ones who are okay making mistakes, but they don't want to screw up the guy in the cubicle next to them as well. So Facebook, Etsy, Amazon, Google, everybody have spent years, I think Salesforce has done this too, they've spent years building out a system that gives not only the confidence to people that if they release this and it's a failure, they can quickly recover from it, but that if they do that, they can also quickly recover and not cause problems for the people around them and hurt their performance reviews and hurt their day and make them come in late to fix the problem they introduced. So they all have a different strategy for doing this, but all of them sort of revolve around this idea of like small releases rapidly that can be then rolled back rapidly. They have an entire battery of test cases that they run every single check-in that goes through, and if anything fails, it goes back. And this is actually what it kind of, this is, I'm actually realized I was skipping ahead. So this is the sort of continuous integration deployment sort of model that we're looking at here. This is continuous integration specifically, but you can expand this out a little bit to be continuous deployment as well. So what this does is it creates a system of checks and balances. So it's like a code check-in on steroids. So if things go out, they get put into a queue, they get tested, either through automation or manual or both. And if they pass, they get put into the thing to be deployed. And then at a specific point in time, things are just deployed. And the version is advanced. And that becomes the new gold standard against which everything else has to be checked in. So this is what you're looking at if you want to do continuous deployment. And this is why automation is key to it, because you don't have time to run a week-long regression suite or spend a bunch of time trying to do a full end-to-end functional test pass on it. So you end up creating, like I said, the smaller releases that then go out. Okay. Now that we've talked about that, are there any questions about these definitions?
There came in once that says, please explain version advanced.
Okay. Version advanced means that it's the next version. It's just that simple. So it's deployed in the test environment, test cases are run, they pass, and that branch becomes the new master. And you advance that version. Now, the versioning is very important because you can't roll something back if there's not a version associated with it. Because again, they want to be able to not just have the test cases be able to either fix forward if there's a problem, or they want to be able to roll it back if there's a problem. Generally, people roll it back, but sometimes they decide to fix forward. Depends upon your culture and what you want to be doing. I think Facebook fixes forward, Etsy rolls back. So, and you can't really do that unless you've stamped it somehow to say, this thing that we've pushed out is this specific item. And when you roll it back, you mean everything within that specific stamp is rolled back, including things that may still be working. So again, this goes into it. So this is also why the very nature of it being rapid and small is what makes this possible. Because again, if you spend like a week and you put a bunch of stuff into that release and then want to roll it back, you've now lost a week of work for everybody when you roll it back. So that's what that means when we talk about versioning and version advance, is until that passes, you don't actually advance the version. You just don't put it into the check-in queue and it just gets rejected. Just like it would be if somebody reviewed your code when you did the pull request and said, nope, you would just reject that request. Same thing happens here, except there's a process for doing that that's a little bit further down the pipeline.
All right. Curtis, there are two more questions. I'll quickly read out them for you on the definition. Justin says, looks like you defined two phases for testing. How do you deploy continuous testing in this? And
okay, let's see. Yes. Because again, we're talking about branch validation, we're running the test cases against that specific branch. So again, this goes back to having a test suite that can test on multiple different layers. So we're running through and we're saying, I'm testing something into the, I don't know, we'll just go from a functional standpoint and say that I've got something I'm checking in for account management. You run the account management test suites and it passes, or you may have some validated things. And then if it passes, it goes into the queue to be in the next release, the next possible release package. If it doesn't, it basically just goes back and gets rejected, just like in a code review. So it's just another layer of testing around the code review other than just static line analysis, which is basically what's going on. You're basically doing a static code analysis as a test for the standard check-in review. This is also saying that every check-in should have test cases for it. You run all of the test cases for it and the associated code base. And if they pass, then you go ahead and put it into the queue to be part of the next release. So it goes from saying a functional point or a unit test. Branch validation is running the system tests to say, if I integrate this code into the overall system of account management, does it break or not? Version advanced is running on the integration and maybe even the end-to-end point. So the other idea is there's testing happening throughout all of this. And again, like I said, even a code review of somebody looking over it is a test of a sort.
So one last question on, yes. Yes, in fact, Justin says thanks. That makes more sense.
Okay.
There's another last question here from Joel. He says, what's the difference between continuous delivery to production and continuous deployment?
It's basically the same thing. I'm not sure why people are using the phrase continuous delivery. If there is a difference, I don't know about it. Again, I'm not an all-seeing, all-knowing person, so maybe there is a difference I don't know about. But the experience that I've had and that we've had is that it's basically a synonymous. Continuous delivery, continuous deployment is deploying to the production environment and you're working on it there. Continuous delivery sounds like the same thing to me when people talk about it. So I don't know if there is a difference or not.
Okay, we can get started again.
Okay. Okay. Again, I bring this up just to sort of rewind a little bit. I bring this up to say the most common use case for having automation injected into your system. Also demonstrate why, and so thank you for the question, Justin, about why we have multiple areas of test in here, because that also demonstrates the need for concentrating on things like multiple layers of testing, having a robust system that tests the code itself before we even begin looking at how does the user interact with it. Because if you look at how much testing is going on here and how fast you have to do it, unless you have a vast sea of testers that can sit down and do all of these things, you're never going to do this with manual testing. It's just impossible. You've got, every 11.6 seconds, someone's going to have to be running manual test cases on these things, and that's not going to happen. So you've got to have a level of automation. You have to have humans looking at it and testing things, of course, because again, computers are never going to say that looks weird. Even with quantum computing, that's simply introducing a third state between on and off. You have on, off, and on, off. So they're still not going to be able to say that looks weird. So humans will always be a part of this process of testing, but the repetitive stuff, the stuff we need to have happen rapidly, continuously, and consistently is going to be taken over by computers and should be, in my idea. Okay. Now for advancing. So here, we're going to go through this sort of rapidly. These are some of the sort of more popular tool sets that are out there for doing automation. I'm a big fan of not reinventing the wheel. So if somebody already has a robust and sort of field-tested solution for automation or for testing that's out there right now that has a good user base or a good paid support, then I'm all for using them. I'm also for having the right fit for the tool. So like I said with using, say, Slim or using some other processes, I don't like forcing a process because we have a specific tool onto a group. I've seen this happen with, I'm not going to name the tools, but some of the tools, because they are completely independent and require a coding language that nobody really uses anymore, sort of force this siloed approach to automation because the teams can't really talk to each other because they have completely different skill sets and different things they're doing. If you have a waterfall type system, which again is perfectly valid for some software development, that sort of a silo program, having a tools group makes sense. If you are running like an agile thing, like say a Kanban or a lean system, having a silo group does not make sense. So I would not go with that sort of a tool. I would go with something that may not, be as robust, but could actually integrate into your actual process system. So I'm saying this before we get into this thing, so before people start asking me which is the best tool, which is the one that you use, blah blah blah. That's not something I'm going to say. This is just sort of introducing you to some of the tools that are out there that seem to have a good track record and seem to be more widely used. So you can sort of get a head start on your idea of doing some sort of analysis to say, which of these packages is going to be the better one for us to be implementing in our system. All right, let's jump into it. Here's an example of some of the basic test engines that are currently out there right now. TestNG, which is a system that's used for the Java code, and it's inspired by JUnit. This is sort of an advanced system, and it does things that I really like a lot. It allows you to do asynchronous testing, which is one of the things that you have to be able to do when you're running, like, say, a continuous deployment. I didn't talk about that yet because I knew I was going to be talking about TestNG and some other things. If you want to get into continuous deployment, you have to be able to do concurrent testing. Again, you've got releases going out that are sitting on top of each other. They're in a queue, but if you have to wait for every single test case to run on every single possible check-in, it's going to take forever. So you have to be running things concurrent with each other. Whether that means you're running multiple releases at one time or whether that means you're running multiple test suites on the same release at one time, you have to be able to do that. So you have to have an engine that can support that. TestNG and some of these others on here that I'm looking at allow you to do that. It also has labeling, which I've talked about before, so you can label your test suites beyond just putting them into a suite. You can label the test case itself to say this tests the following stuff. You can have check-ins associated with it. You can have all these things you want. Anything you really want to do, you can put in there, and then use that as a logical grouping for running a test, for running test cases in a suite as you launch dynamically. The X unit, I put all of these in together. It's like JUnit, RUnit, NUnit, red unit, blue unit, yellow unit, whatever you want to call it. MS Test is basically NUnit, but they've expanded it quite a bit, but it kind of uses the same sort of structure for running the test cases, so I put them all together. This is the old master of unit testing and test framework and for test engines for automation. It was one of the first ones that was out there that was widely used, that was open sourced. It's had over a decade of sort of active user involvement with it. It's stable, it works, the knowledge base is huge for it. You generally don't have to worry about an automation engineer knowing one of the XUnit languages because they almost all of them will. It's just an awesome little thing to use. So then we have another one which is sort of falling out of favor right now, but it's the water WADIN area, which is based upon either the native Ruby or .NET libraries from Microsoft. Again, water being Ruby, WADIN being the NUnit or the .NET library. If you're working with sort of a web request-based system, these things I like a lot because they allow you to sort of treat the DOM object in the code as if it was an actual code library. You can pull things out and simulate user interactions, but you can also do things like manipulate a table as if it was an actual data array. So that's actually pretty cool. MVC framework I put in here as an example of some of the more, some of the newer and more advanced test frameworks. MVC is used for the Java Spring applications, but one of the big things about that is it allows you to create test cases that have what they call expectations and sort of ideas around what this test case should have set up before you even launch it. This allows you to launch a test case on the user interface without having to go through all the things like sign up and click on this, click on that, click on this to get to the page you want to actually test. You can launch that page straight off and run the test, which is an amazing thing to be able to do if you want to speed up your testing and also have things less brittle. Espresso is the native automated for the Android operating system. It's similar to MVC in that it allows you, it sort of sits on top of the Android code, which part of the Android code is that idea of the expectation as you move back and forth between different screens. So it has built in that capability as well. Automating with Espresso was a little bit of a learning curve for me, but once I did, I loved it. You could, like I said, I could just launch a page straight into what I wanted to be, run a test case, and close it. I didn't have to do all of the crazy stuff of waiting for stuff to get to places and wait times and things like that. I could isolate the specific thing I wanted to test it, and be on. I put in UI Automator because that is the engine that Apple uses for testing all of their iOS app, all of their sort of user interface testing. It's basically just JavaScript. So but it's there. It's kind of what you have to use if you're going to be testing on an Apple system. So here's some extensions, and notice I put Selenium here because basically it is an extension for being able to test into the systems. It's sort of a web extension on top of that. So it's not a language by itself, it's an engine for running a language that you walk through with it. It's probably the most popular one out there right now for web automation. It's the one everybody knows. It's got the huge amount of use. It has been expanded out now to have multiple libraries you can use within it. You can use an IDE to record and play back test cases, which I think is a valuable tool to use when you want to get started automating, because it identifies the things and gets started running, which sort of moves us into the Appium and Calabash. Appium is started out as an extension for Selenium to be able to interact within browsers, within mobile devices. There's since been some divergence. The core engine is still similar to Selenium, so you can actually create web suites that integrate, which we've done multiple times, where we can integrate, say, doing something on a mobile app and then checking on a website to see if the expected change happened. It's actually pretty awesome to be able to do that and not lose your session state, which using Selenium Grid and things like that allows you to do. Calabash is a Ruby-based system that is, again, being more widely used within mobile automation. It is a sort of, it's not a statically typed language, so a lot of people like it better for testing against these things, and it lends itself more easily to say, natural language testing or behavioral-driven development using natural language engines like, say, Cucumber. So again, talking about behavioral-driven development or specification by example, that's becoming huge. So again, you've got, like, say, Capybara, Fitness, Cucumber, JBehave. These are engines, these are sort of runners that sit on top of your code base and translate that text into blocks, which you can then write code around that block to say, when you see this, do this. This is incredibly helpful because it allows a conversation between the people writing your requirements or your user stories or your acceptance criteria, which supposedly it should be at the acceptance criteria level. So when they write it, these tools, like, say, JBehave, running within, say, Jira, can look at that requirement and parse out the blocks of actions to be able to do, and then do that action. So your user acceptance criteria becomes a runnable test case. This is wonderful because it starts getting the people writing the user acceptance criteria to start thinking of it as something that's testable, and it starts the development team looking at it saying, when they say this, what do they mean, as opposed to just assuming they know. So it creates a dialogue between these two teams, which then creates a jargon or language that they can use to communicate more effectively back and forth. I've seen this happen multiple times, and when you look at it that way, the time for estimation and design and things shrinks rapidly. I've seen teams adopt behavioral specification by example using things like Fitness, Capybara, whatever. And I've seen them go from taking 2 to 3 days to do the sprint planning or the estimation or onboarding, as well as sort of invalid defects that are caused by a misunderstanding about the requirements. I've seen that 3 days go to, say, maybe 2 hours on the first day, and I've seen the amount of test cases, amount of bugs entered because of an invalid idea about a misunderstanding drop to 0. So it doesn't happen immediately, but over the course of, say, 4 to 5 different runs of this interaction, of this dialogue, it drops significantly. I hope that got you all excited, and you'll start doing this now because I think it's awesome. Looking at the web request layer we were talking about before, you have the 2 things that are probably most used are SoapUI and then tools like VCR. SoapUI is sort of the advanced thing for capturing and then sending web requests through either RESTful or non-RESTful API calls. VCR is an example of a tool that are coming out now. And what they basically do are record what I call Groundhog Day tests, where you record actual traffic that's being sent back and forth at the service layer, and then you play it back within your test environment. So this creates a slice of time for what real interaction is going to be on your system, and then says, replay that on our test system to see if anything breaks. It's not perfect because as you introduce new stuff, that recording is going to be slowly more and more non-reflective of what's going on in test. You have to refresh it, but it's a great way to get quick sort of beta testing or dog food testing going on within your system at a system or integration level. Then there's the giant beast in the room, which is HP's suite. It's now called UFT. It used to be Quick Test or QTP or Quick Test Professional. Again, I think it's a great tool. It's robust. It's got a lot of things going for it. But the trouble is, like I said, it tends to sort of create a silo, which is fine if that's how your company works. Again, fit the tool to the process. Another one that I've seen going on that may be sort of fading because I haven't heard it as much as Test Complete, but it's another one that's proprietary. I put it up here so that people can look at the system and say, I don't need to go out to open source. I don't need to ask my own questions. I can submit a support ticket, and they'll come back to me and talk about it. That is the benefit of buying a system versus getting one that's open source. Again, everything costs money at some point. Either it's opportunity cost with, like, say, an open source system where you're going to be answering your own questions and spending time when you could be doing something else on trying to resolve issues or find out answers or maybe even do a fix yourself, versus the amount of money it costs you for that support license, but getting an expert to respond to you rapidly and not losing that time when you could be doing something else. So that, again, needs to go into your tool analysis to say which one is best for us. Do we want to do our own support and then lose the ability to be doing other things during that time, or do we want to pay for the license and then have an expert just tell us what to do or solve the problem for us or do a bug fix to the code if there needs to be one? All right. So that's kind of the end of my talk. So, and it seems like we're actually over, and I apologize for that. Smita, if you want to send me the questions, I will respond to them.
Yeah, there are
and we can get
quite a few.
Yeah.
Iram, Justin, John, and there are quite a few of them from with respect to DevOps and test automation in agile sprints from Azure. Yeah, I think you won't be able to do all of them. So maybe I'll just send you all the questions and you can post your response on softwaretestpro.com.
Yeah, I can do that.
Yeah. Sorry, guys. We are running late. Yeah.
And also, if you want to ask me directly, you can go out to @cowboytesting.com on Twitter. Or not at Cowboy Testing on Twitter. Yeah. And that's where I live. If you're not on Twitter, get on Twitter. It's not the best forum for talking, but it's a good one for getting like quick response to questions. I'm working on getting a blog restarted as well, but that's probably not as good because that's just me rambling on my own thoughts. So, you know, go out to Twitter, start friending some people and getting that happening. Get some people lined up to be able to meet at the conferences when you go there because they can introduce you to other people. And also, please do attend conferences like STPCon or the other ones that are happening out there, because that is the best way to get re-energized for what we do as software testers and quality people as a profession. You'll meet people who are just as passionate about you about the thing that we do. And that feels like a vacation to someone like me. So please do that.
Absolutely.
All right.
Yeah, thank you so much, Curtis. Thanks for your time today. It was a very insightful session with lots of practical tips and key information and understanding on basics of automation and the tools and how to get started with it. So I'm sure our attendees found that very informative and useful too. So thanks again, and I hope to see you in Washington.
Thank you.
Everyone here, this concludes our webinar for today. Thank you everyone for joining, and more importantly, thanks for being so engaging and making the most of the webinar for yourself and for the whole group. Stay tuned for more webinars and online trainings coming soon. And if you haven't yet signed up for the upcoming webinar, which is Make Your Automation Behave, Extending Your Framework for BDD, that is by Angie Jones, which is scheduled to be on 28th of June. So the link is up for you. Please review it and register at softwaretestpro.com. All right, thank you everyone. Have a great day. See you all in Washington.